Hello, and welcome to webinar of CodeNow related to vendor management, really how to make sure that you are in control, not your vendor of your company. My name is Marek Pikna. I am a solution architect here at CodeNow, and today we'll be discussing this topic at a webinar. So I'll first start with sharing a presentation here. And we can jump straight into it. So today's topic, as mentioned, is related to vendor management in software development. The agenda for today is to quickly go over outsourcing itself. When is it beneficial to work with vendors? When is it not? And we'll be taking a look at selected risks of outsourcing. How come these risks come to be? Why do they come to be? And we'll be taking a look at internal developer platforms as a mechanism of risk management. We'll also take a look at an IDP itself, just to drive the point a bit further. And of course, there'll be room for Q&A here. So if you have any questions that come up during the presentation, feel free to send them into the chat and we'll have time to go over them. So let's first discuss outsourcing itself. When is it beneficial? Because of course, outsourcing and working with vendors in IT is an absolutely massive market. Almost every single company of enough scale works with certain vendors. So when is it beneficial and when on the contrary, we should not really be going that way? This is something that's easily answered by domain-driven design, which sees essentially three major business domains when it comes to software and companies. The first such domain is the core domain. That is your company's business differentiator. That is your differentiation. That is the complex area. Essentially, it is impossible to buy this off, because if it were possible, that means there is not really any reason for your business to be, as the problem is already solved easily. Generic domain is all the software that's related to company's operations. It's very generic, something that your company does require, but not something it makes sense to focus on. As an example, it is very unlikely that anybody in the company would decide it makes sense to develop your own CRM. The support domain then is essentially the glue between these two domains. So as mentioned, core domain is realistically impossible to fully outsource. Sure, you may have certain consultants working with you, but in essence, that is your domain to solve, to find solutions, to program them, and so on. The generic and support domain, however, makes complete sense to outsource, as that may become significantly more cost efficient, may become significantly faster, and so on. So makes sense to work with vendors, makes sense to outsource projects, as the vendors may have deep knowledge of specific areas, of specific solutions, of existing products, of the markets, which you may not have. Understandably, as that is not your domain, and they may bring them over to you. However, it should be exactly in these generic and support areas. In the previous webinar that we've mostly discussed strategies for effective cooperation with vendors, how to make sure that they deliver properly, what can we do to protect ourselves. Today, we'll be discussing more on the topic of risks, how to manage them and how do they come to be. The specific theme that we're going to be, that is overarching of all of these topics, is what happens or how does it happen when a company is managed by the vendor themselves, rather than them managing the vendor. A simple question that we can ask here already: do you manage your vendor or do they manage you? The terminology or the statement that we'll be using here is essentially vendor-led architecture. On the right-hand side, we can see an image inspired by the OSI layer of networking, but essentially it shows the hierarchy of constraints in enterprise systems, meaning that from the top, we have very soft things such as business processes, enterprise decisions, designs, and so on, consultancy patterns, architectural knowledge, all of that very commonly made on paper. The paper can handle everything and anything. And the lower we go, the more constrained we are. The more we work with specific environments, specific infrastructures, all the point to the runtime of the code itself. The code itself needs to be adaptive. It needs to be able to handle all of the requirements pushed from above. And essentially, when it comes to working with vendors, a vendor can be in every single layer here. We may have a vendor that develops software for us, meaning that they are in the bottom layer. Very likely, we have an infrastructure vendor. for instance, a cloud vendor. Everybody essentially has vendors for delivery tooling. Nobody decides to build their own Git frontends. Nobody decides to build their own CI/CD tools. Makes complete sense to work with vendors there because, once again, those domains are not really within the core layer. However, it's important to note that all of these vendors, we may get to this vendor lock-in, the vendor-led architecture in any of these layers. Every layer may result in extreme vendor dependency, which initially may not be too bad, actually, because there are certain benefits to just working vendors going one direction, because it does significantly speed up time to deliver. It does significantly enable movement forward. It's not until later that time goes on and we see what is happening that we kind of have to stop and go, okay, but 2 years from now, are we still going to be working with them? If not, how do we handle that? Because when the lock-in happens, we run into the cost asymmetry. How expensive is it suddenly to lose the vendor, to offboard them, to go to another one? What is the long-term way of working? That's exactly what is happening in this vendor-led architecture, that a vendor becomes the master of a certain layer, and that enforces a specific model for all the layers below. If we have a vendor that specifically decides, for example, level 5, all the architecture for us, that's what we need to do. That's what we're working with. We cannot get away from that. So let's talk about the risks themselves. The common situation why what happens is that very often vendors deliver using their own specific stack. Important to note, stack in here is not really a topic of a specific framework or a specific programming language. It's more a question of how do they deliver specific software? How is it deployed? How is it updated? Who maintains the software? So on and so forth. Knowledge and understanding very often stays only for the duration of the contract. And once the contract is over, that's the time that the software is handed over. But suddenly all of that knowledge is just gone. So once again, we'll of course have some kind of a project extension, some kind of a change request, and suddenly we're looking at 10x cost increase. We are not able to handle it ourselves. And that's very often when the common statements come in, such as we can't do this, only the specific vendor can, only they know what's up, they know what's happening. If those are sentences ever uttered in any kind of a meeting or an email exchange, can you truly say you own your solutions when you're not able to actually manage them end to end? So why does this exactly happen? As mentioned, very often it's because vendors take over unless enforced to their own strategies, their own tooling, their own tool sets. So building, delivery in general, stack themselves, deployment, the hosting, configuration, preference strategies of those. They own their own monitoring, they own their own infrastructure preferences, and all of that may suddenly enforce your company to go a certain direction, which may work and may actually be really fast and just not problematic at all. On the scale of 1 or 2 completely independent vendors, actually, it may feel really fast moving that direction because you don't really need to focus on the projects themselves. But once you go to a certain scale or project complexity or dependency between vendors, or maybe even with your teams, suddenly how do you take over? Maybe you're unhappy with the vendor. Can you onboard them and replace them? How do you actually take over the project once the vendor leaves? How do you maintain the project? That's exactly the kinds of questions that you need to be able to answer. So let's take a look at certain risks, just a few select ones. First one is related to intellectual property ownership. Now, very often people consider intellectual property mostly in the terms or the area of source codes or binaries or some kind of containers and so on. The idea being that if you have source code, you can do things with it. You're able to, even in the case of disaster, start the application again and start working. Let's work with a hypothetical situation. Let's say that for our business, we are working with a certain vendor who promised us a specific project of a reservation system, software that we're not going to build ourselves, software that we're going to give over to a certain vendor. Now the reservation system should run on our own infrastructure. We receive the source codes, we receive the deployable binaries, any kind of artifacts to actually make sure the software is running. And we're happy, the software is good. But now all of a sudden a security incident occurs. There's a bug in one of the libraries, one of the dependencies we're using. Fortunately enough, the solution is quite simple. We just need to update the dependency. Now the question starts, can we actually? How do we know it won't break anything? Maybe there was a breaking change that's going to be affecting us. How can we test it? How can we make sure? Suddenly this, what should be simple an update, is going to be painful. Typically, of course, an organization goes, okay, you know what, it's going to be the fastest to just do it and see what happens. We would, of course, like a bit more confidence. Then even if that works, long-term maintenance, we may need new features, maybe alerts for people that their reservation is coming up or that they can remove their reservation, any kind of additional feature requests. Do we actually know how to develop them? Do we actually know how the system operates? Is it documented enough? Do we have the knowledge? Are we able to do it? Even if I develop it, am I able to push this onto prod? Am I able to actually build a new version? Am I able to configure it for various environments? I need to be able to answer all of those questions, and even more actually, to be able to have full ability end-to-end to maintain and develop certain software from local dev, from my own machine, all the way to a production environment. It is a very similar topic when it comes to cost asymmetry. Cost asymmetry in vendor management is essentially the topic of the cost of onboarding versus the cost of offboarding or change or replacement and such. Of course, onboarding has a certain cost. Cost given by the actual cost of the vendor and the project, cost defined also by, for instance, internal training, by utilization, possibly other places. Very understandable. But what is the cost of actually offboarding going into another direction? For instance, if I use certain Git provider, in essence, source code management should be quite simple and quite cheap to just go somewhere else, possibly even free. But when it comes to software, or honestly any layer here, if we are dependent on the vendor truly, what is the cost then? It may even go 10x, maybe even more, because it's no longer just a topic of changing the vendor, changing the solutioning. Solutioning is integrated across our systems, may not be as cheap. And when that happens, the vendor is in control. The vendor, even though they may not know they are in power, realistically they are. So that is another risk which may occur. Now, essentially here, we already need to talk about CodeNow as a governed execution tool. Or let's first actually just finish the shadow IT that's going to make it easier. So one of the fears of enterprises is really to shadow IT. Now, just to quickly put a definition here, by shadow IT, we mean development and utilization of various IT solutions without IT overview or oversight. Now, this is very commonly caused by what essentially is a battle of two areas. Here we have certain business units, and what is a priority of a business unit? A product team, or really just a business organization, their priority is change. They want to have change, they want to have new solutions, they want to quickly try them out, they want to rotate things. On the contrary, what is the priority of the IT or platform or ops or DevOps or any other term? The priority is stability. The priority is to minimize change. So essentially here we have two completely conflicting interests within our own company. Now, why does this happen? Why is it so common that as a result, very often business units start developing their own solutions or just outsource things without IT even knowing? The reason typically is exactly that. In reality, for an IT organization, ops, DevOps, SRE, doesn't matter, their customer, in essence, is the product team, is the development team mostly. It is the developer themselves as a person. That is their customer, that is who they're working with. Very rarely do they have capacity for actually working with others. Very rarely is it actually possible in a reasonable time frame to go in some direction. As a result, business units suddenly start developing on their own end, suddenly start outsourcing without IT even knowing or having oversight here. As a result, they ignore certain standards because they, in a certain sense, have to. Otherwise, the change that they require would be way too slow, way too painful, way too difficult. So let's talk here exactly about CodeNow or IDPs. So CodeNow is an IDP, meaning Internal Developer Platform. Internal Developer Platform is a platform which standardizes and provides one-stop software delivery platform. The developer is the user of such platform. They create and deliver applications through a standardized path. We can see the idea here on the right-hand side image. Essentially, the IT teams are in the bottom as the existing infrastructure and working with it. And on the top, we have all the developers, the product teams, the business units who require some code, who require some solutioning. And they're kind of basically having code now exactly in between, or an internal developer platform in general, which makes sure what is the strategy to develop, what is the strategy to deliver, to deploy, guardrails, ensuring auditability, and so on. The goal here is essentially twofold. The first is empowerment of developers. That results in independence of teams because they no longer need to create a ticket for everything and requires insignificant speed increases. The time to market simply just goes significantly lower. At the same time, what is the topic of interest here related to vendor management is the standardization and process enforcement, meaning there is a single process on how to do things, on how to deploy software, how to run software within a company, and provide standardization. As such, any team, be it internal, vendor, outsourced, however, may create an application workload, and IT is able to run it very easily. What IDP essentially does here is complete separation of dependencies. As we'll see, that's not just a topic here, it goes all the way to that layered hierarchy. So essentially, we can think of this as a term of governed execution. The idea is that we have an execution platform where we have a lot of strong governance. As a result, IDP essentially separates these constraints. So as mentioned, any software we're developing to solve something in an enterprise is constrained by something. Slowly but surely, my software here as a code is constrained by infrastructure, by delivery, by design, by business requirements, and so on and so forth. What an IDP actually does when introduced into a company is that it very beautifully separates these constraints. So at the top, we have the human parts, in essence, the business process layer, the design, what we do on paper, really, what we design, what we do in meetings, what we do in our heads. Completely separated from that is the machine part, the part, where do we run it? How is it being run? What is the actual code being executed? Essentially, the machine portion that is completely abstracted by the IDP. So we're able to just put these difficult, conflicting, and constraining areas, topics, into their own boxes so that we need to work less in such constrained environments. So we obtain clear definition for workloads and creation. The vendors that we're working with are given specific rules of engagement. We have a specific model of delivery. The platform defines potential cooperation with other vendors for the vendors themselves. If we onboard one for developing software, for developing a certain backend, and they need to provide certain events for another vendor software, suddenly there is a very simple strategy, very simple platform how they can cooperate. The company also receives things from having an IDP, not just this nice separation of constraints. It's also related to rules of takeover. It provides, essentially defines a takeover model. And of course, provides monitoring, observability, complete governance, complete auditability for the company. So when we're talking about intellectual property ownership, when software is created within an IDP, the IDP ensures clear configuration management, creates clear definition of build strategies, CI/CD, golden paths, templates, scaffolds. It ensures monitoring. Is it running? Is there a security incident? What is the static analysis, and so on and so forth. That means that company does not take over just source codes in a vacuum, hoping that it works for the best. They do take over the complete ability to maintain the deliverable end to end, from a local dev machine all the way to production. That, of course, completely reduces, maybe even minimizes dependency on a single vendor in a long time. It provides clear visibility into the delivery. Similar topic here related to cost asymmetry. As mentioned, one of the problems or difficulties and pains is especially if the vendor lock-in happens on a high layer, because then they completely decide everything below. And IDP, of course, completely makes this disappear because it provides an abstraction of communication between the two. so the two can always change, needs to be on the level of IDP. So the difficulty of offboarding a vendor becomes much, much easier. The IDP for the higher level, for the human part, as I'm calling it in essence, defines way of working. How do we do this? What are we working with? They no longer care about the specific details, the gritty technical details below. For L1 and L2, for our actual code, for our actual machines, the using them part is directed once again by the IDP. So IDP enables prevention of a vendor lock-in on its own level, but it also protects company across multiple processes. And we've also discussed shadow IT, where very often what happens in companies is that business units go around IT department themselves. And now with an IDP, this becomes a significantly easier topic. Why is it difficult to enforce these standardized patterns? It is definitely not the case that people want to go around and break rules. However, without proper tooling, typically, very commonly, the process of working with IT converges to a ticketing one. I require access to a database, I require a new instance, I require machine something, I simply create a ticket. Of course, if I have far too many customers, I simply cannot handle tickets for everyone. An IDP essentially defines a contract for the platform team to work with, meaning that from the bottom, the platform team defines a certain contract, which is enforced by the internal developer platform. And from the top, anyone can be a user of the said platform as long as they have software to actually run and deliver. This means that they no longer need to create tickets. They simply need to work with a contract. They don't work directly with a customer. They're abstracted from that because they're working with a user of the platform. So platform defines a standard which is easy to use and also easy to enforce, which is really important. Once it is easy to enforce, it is really simple and even beneficial for the vendor, in all honesty, to give them a standardized way on how to manage things so that they don't need to reinvent the wheel specifically for one company. So the conclusion here, before we'll take a look at CodeNow itself, is that outsourcing may be extremely beneficial. It is, however, important to note or to consider what exactly are we outsourcing. It is very beneficial not to focus on one's core systems, but rather on the other domains, where IDPs very often fit in. However, it's also very important to manage risks for working vendors. There's actually many more of them. We've only covered a selected few. But what's really important about that is that IDPs, even though we tend to think of them as a topic for developers, because the developer is the end user, in a reality, it's a topic which enables cost-efficient and effective cooperation between a company and its vendors. It's not just a topic of our own internal developers. It's something that helps us make sure that we are able to work with vendors and long-term protect our assets and make sure that we actually own anything that we should own. Also, once again, if there's any questions, don't hesitate to put them into the chat. We'll quickly take a look at CodeNow as an internal developer platform. And then if any questions are going to be in the chat, we'll definitely have the time to answer them. So here we have CodeNow, the view right after I log in. And every single card here is a certain application within our own environment. So here we, for instance, have a demo application, which consists of certain components. If I were to create a new application, we can simply do it right now. So we create a new application. We mentioned risk. Let's, for instance, work with risk. So risk management, which will work in a certain environment. I have a webinar one. I'll confirm, and we'll create a component. For this case, let this be, for instance, a front end. So I'll call the component in a certain way, and I'll say that it needs to be created with a certain React scaffold. So I click confirm, and now the component is being created. What does that mean? That's actually very simply the Git repository for essentially a Hello World application, which is created here, and all of the configuration metadata that I may not even care about that I require, which simply is how is it going to be deployed, how is it going to be built, and so on. So if I click here, I can really open a repository. This is just a Git repo, and I, as a developer, would be able to open the source, clone this, open the source code with my favorite text editor, and do any kind of work I want to. Then I can, of course, run a certain build. So here, let's just release the hello world. We'll release it in a certain version, and this will be running. So let's give this a while for the pipeline to finish. In the meantime, let's take a look at the demo application we already have. So as we can see, it consists of certain components. There's an API gateway, there's a business logic component, and there's front end. We can see the build history, we can see the versions. I may look at certain other data. Each of these applications has a specific package, which does have its own specific version. This is really important to consider because what code now enables or ensures is that we have one specific package going all the way from a dev environment to production. What changes is only the configuration, never the actual code itself, ensuring and guaranteeing the parity between dev and prod. Hence, we have a deployment configuration. When we select such things such as on prod, we are going to use that database. On dev, we're going to run in 2 instances. On prod, we're going to run in 6 replicas, so on and so forth. And then we are able to deploy. So we'll be taking a look exactly at the deployment of our own example application. Let's keep the build running. It's not going to take too long. Of course, if we wanted to, we could take a look at the details of the build, of the pipeline. What is it actually doing? What is it going to do in a certain time, and so on. What is important to consider while the build is running and what works, once again, nicely for the topics of vendor management, code now provides or really makes sure to have control visibility monitoring. That's exactly what we're getting with an internal developer platform, pardon me, not just the creation and delivery process. And that essentially means that all of the topics related to logging or tracing is visible. We're able to see status of our own cluster, for instance, which here is the delivery target. How is it consumed? We are able to, for instance, take a look at details onto dashboards of how it's consumed, what about the network, so on and so forth. We're able to take a look at static analysis, or we're even able to work with certain reports. So, for instance, on application level, I could take a look here at our risk application, and I would see that a certain user has already requested certain builds, has created certain packages. Here, that's simply from the past from another webinar, but the idea is still there. We have all the information, which is auditable, which we have access to. When working with vendors, we know exactly who did what, where, when, and how. All of that information is strictly available to us. In the meantime, let's see how our risk application is doing. I think I need to refresh here. The build is still running. But okay, we're already in the static analysis portion, so we'll be done very quickly. So now, of course, what this results in is when working at a larger scale, especially with multiple vendors, we obtain all of the information about essentially high-level information about our environment, meaning what is being deployed, what are we working with. Here we can, for instance, see certain components, what version are they in. We can see if anything is being deployed anywhere. We can even see metrics related to DORA, for instance, about deployment frequency, lead time for changes, so on. So we have high-level documentation of our own software environment. We're able to know exactly who is doing what in what state. We are able to take over because we have access to everything. We have access to all the configuration management. We are simply able to manage the software end to end. So here we can see that the build has finished, which means that we should be able to create an application package. So let's create one. The package will just contain one component. We'll push this into our webinar environment. We could run certain specific configuration. For our case, there is not really any specific one that we need to. So let's just start the deployment part. So the deployment in RUCD is being started right now. And hopefully in just a few seconds, we should see how this is being deployed into a certain environment. There we go. and will be able to access the front end in just a few seconds. This essentially means that the developer themselves, or even a business user, is no longer dependent on creating tickets. The vendor is no longer having to find certain ways how to go around IT. We are able to create our own components within our own environment via our standard processes, build it through our standard process, and we can see via the URL, this is actually something that the user could get to. So that was just a quick walkthrough of CodeNow. If you have any questions about CodeNow or internal developer platforms in general, don't hesitate to send them into the chat or reach out to me via email. The email can be discovered right here. I actually forgot a digit here. And since I don't see any questions in the chat, I thank you very much, and I wish you a pleasant day. Have a great day.